we're going to start talking about, and I bunch 8.4, 0.5, and 0.6. It's still chapter 8, but it's all in one. I do it all in one shot. I find that it's better to just talk about it all in at once. So far we were just dealing with one-dimensional objects, right? We were just talking about either the length or the width and so forth, right? We did not talk about areas and we did not talk about volumes, okay? So that's going to be new today, but the same applies, the same sort of basic concepts stay the same, okay? So I will start with the notes here and then we'll do some examples. Okay. In dealing with one-dimensional one-dimensional or linear values, we used, so we're talking length, width, it could have been height, it doesn't matter, right? We use the following, right? Always knowing that the scale factor is going to be the, for example, length of the new over length of the original, okay? We knew that. And I never added the length before, but now I am, because that's what it's implied, right? The simplified version is just new over original, but when we're talking length, we actually, right, talking about both lengths. Or we also use this one, which is the length of the diagram, length of the actual. And some of you are, the question has been asked, you're not the only one asking that question. It's like, well, are they both the same? And in essence, yes, they are the same. It's just that sometimes it's better to use this language as opposed to that language. But really, the original can also be called the actual, and the new can be called the diagram. Okay, so let's write this down one more time because it's gonna be very important for us to just use these ones over and over again. Okay. So this is the one I'm going to box in. Push. Yeah, there you go. So there we have that. And I will give you a different version of this formula, which is just really rearranging everything, okay? Because if you were to cross multiply, you get that the new is really just k times the original, right? That's just rearranging the formula. So you could say that the new is going to be k times the original, or the diagram is going to be k times actual. And if you're wondering, oh my goodness, which formula should I have on my study sheet? I would say for sure these two. This is just a derivative of this one, okay? I'm just cross multiplying and dividing and you get this essentially from that, okay? So sometimes it's nice to have this one to quickly get the new length or the new height or the new width and so forth. So this would all be considered one-dimensional. So put 1D somewhere on the side here. I'm going to kind of cut this here and start talking about 2D. So I'll put 2D on the side lines here. And so let's explore this first, right? A rectangle has dimensions of 20 feet by 15 feet. And I'm using numbers that work out nice and easy just to illustrate something. We could have decimals, you could have all various things could appear. Okay. A new version, essentially a copy, okay, will be made using a factor of 3. Find, okay, determine the area of the new rectangle in 2 ways. So I'll show you one where you need both dimensions and one where you don't. So let's start with our original. So I'm going to have a diagram and some calculations and numbers that go with it. Okay. So we have the original, and let's just draw a triangle here, rectangle, sorry. And we know that the longer side is 20 feet and the shorter side is 15 feet, the length and the width. And we'll have our new shape right here. And because in a sense k is equal to 3, okay, k is bigger than 1, so we know that it's an enlargement, right? So we're going to go ahead and draw a rectangle that is longer. It's not drawn to scale. Okay. And so I have my, if I take this, really it's just times 3, right? So we're going to go take that, multiply it by 3, and you get 60 feet. And you take the width, multiply it by 3, and you get 45 feet. Okay, so you have your both of your shapes right there. Let's look at the area of this one. Area of the original would be 15 times 20, right? And so that is 300 square feet. Put the 300 square feet. What is the area of the new shape? It's 45 times 60, right? You take the dimensions that you've converted them, and you get 45 times 60. So what is that? That's 2,700 square feet. So this is one method of finding the new area, where you take both of the dimensions. In this case, we have to multiply it by 3 to get that. in a sense, folks, what happened, how did I get this? I used this formula right here. I said the new width is going to be the scale factor times the width of the original. Okay, so that's how I got that. And the new length is going to be the scale factor times the length of the original, and I got 60. Okay, so you have that there. So let's write that out over here, where you have, let's go ahead and go area of the new divided by area of the original. If you take those two, what would you get? So let's take the area of the new, which is 2,700, and the area of the original, which is 300 square feet. The square feet can cancel out like that. The zeros cancel out as well. So 27 divided by 3 is just 9. Okay? What does this look like? How can you rewrite this as a power? How can you write 9 as a power? 3 squared? Okay. So the 3 should ring a bell, right? My scale factor is 3. And so how have the areas been affected? Just by 3? No, they've been affected by 3 squared. So they've been affected by a factor of 9. So think of it this way, folks. This is 2-dimension. We're dealing with 2-dimensional objects here. So your scale factor is affected by a factor of 2, right? So it's k squared. So let me get my highlighter. So I want to make sure I illustrate that. Right, that is your k there. So it is really k squared. Okay. Therefore, here's your new formula. 2 new formulas that I'm going to give you. K squared is going to be area of the new shape divided by area of the original. Or you can think of it this way, k squared is going to be area of diagram divided by area of actual. These I would definitely box in and have on my study sheet. Okay. So 2-dimensional, it's not just k, it's k squared. We divided the areas up here to show that, right, that it wasn't just 3, it was 3 squared. So we call that scale factor squared. Okay. The reason being is because you affected both dimensions, so it compounds, right? So your area isn't just twice as big, it's actually 3 times as big. It's 9 times larger. Okay. Yeah, go ahead. Backside, or wherever, this will take a little bit of space, so if you only have a little bit of room, go to the next page. Let's finish this before the power goes off. 3D, was that thunder? Yeah, that's what I mean, before the power goes off. Okay, 3D. A box measures 2 inches by 3 inches by 5 inches. Okay, a new one, right? Copy will be made using a factor of 2. Determine the volume of the new box using 2 methods. And that reminds me that I didn't show you specifically how to use the second method, but I'm gonna show you how to do that here. So we're gonna draw our box. So try your best. I know it's kind of, just draw a box like this. Right, I start with the top, and then I just use parallel lines like that. And is our new box, bigger or smaller than the original? It's bigger, right? Because the factor is 2. Scale factor is 2, so it's bigger. So let's make it one that looks bigger than the original. This is the new, or the copy, right? So we have a 2-inch by 3-inch by 5-inch box to start with. And everything is multiplied by a factor of 2, right? So if we consider this length, right? Length, width, and height, like that. I will just do that for the length here. The length of the new will be K times length of original. So what's K in this case? It's 2. The length of the original is 2 inches as well. So it will be 4 inches. Right. So this scale factor could be a decimal, it could be a fraction, it doesn't matter, it works the same way. Okay, so don't let fractions and decimals throw you off. So it's 4 inches. So the other ones I'm just gonna, it's 2 times 3 and 2 times 5, like that. So I'll write down the 4 here again. I'm just gonna show you the calculation to get that first one, is essentially what happens with all of them. So let's go ahead and find the volume of the original. Would be found by going length times width times height, and that's 2 times 3 times 5, which is 30 cubic inches. No surprises there. That's as easy as it gets, right? Volume of the new one would be 4 times 6 times 10. So 4 times 6 is 24, times 10 is 240 cubic inches. This would be the first method of figuring out the volumes, right? This would be method 1. I will show you the second method in a bit. Let's just explore this here. If I took the volume of the new shape and divided by the volume of the original, I get 240 cubic inches divided by 30 cubic inches. Cancel out the cubic inches, cancel out the zeros. 24 divided by 3 is 8. How else can you write 8 as a power? Yeah, 2 cubed, right? So 2 to the power of 3. And what does the 2 remind you of? Where do you see 2? Scale factor, right, that you started off with. So it has been, when you divided the volumes, you realize that the scale factor has been affected by a power of 3. So it's k cubed. Okay, that's what I want you to observe. Okay, so here we go. I will give you formulas. K cubed, therefore, the 3 dots is therefore, if you've never seen that before. K cubed is volume of new, volume of original, or K cubed is volume of diagram over volume of actual. Always come back to these formulas if you are confused or whatever. Try to see what you know, plug it into these formulas, and then solve for what's not known. Okay, so this is method 2 of finding the volume. So I will use new and original, right? So K cubed is equal to volume of new over volume of original. And let's pretend we don't know the volume of the new shape, right? Let's for a second just assume that. We do know our scale factor, so we go 2 cubed is equal to volume of new over, what was the volume of the original? It was 30 cubic inches, correct? I will continue over here. I find out what 2 cubed is, which is really 8. 8 is equal to volume of new over 30 cubic inches. You cross multiply, right? In this case, there is a 1 down here, folks. 8 over 1. Really, so it's just 1 times that. So volume of new is equal to 8 times 30. Volume of new is 240 cubic inches. That's how the second method is always using one of these formulas, only one of them, and just plugging in and finding what you need to do. Okay. Hey. It's Jasmine is making a kite using a scale diagram with a scale of 2 to 25. The fabric used on the diagram is 20 centimeters squared. I will do this. Calculate the area calculate the amount of fabric, the amount of fabric needed to build the actual kite be if fabric costs $275 per square foot, sorry, not square foot, square meter, per square centimeters. Calculate the cost. Calculate the total cost. So you have to ask yourself, first of all, they're giving you something very important, which is the scale right there. So K is basically given in this. Even though this is a scale, you can find the scale factor easily. And then you have the 20 centimeters squared, which is, it's two-dimensional, right? Because of the centimeter squared, you know it's two-dimensional. So we're going to stick with the formula that requires that works with two-dimensional. So K squared, I know, is the area of the new, I shouldn't use new here. What should I use instead? Diagram. Yeah. Diagram over the area of the actual. That's the one I'm going to start off with. Remember 2D, you're going to go to this one that has the K squared and that relates the areas. So what do I know? I know K. K is 2 over 25. I'm going to square it. Don't forget to square it like that. Watch how I put the whole thing in brackets and I square it. I have what? What do I have here? I have the area of the diagram, which is 20 centimeters squared. And watch this. These are the only units that appear, so your final answer will be in centimeters squared, which is the area of the actual. Okay. And so I will continue over here, so it's not too far down here. So 2 squared is just 4. 25 squared is, come on, mental math. No, I'm just kidding. It's been 625, right? You have your calculator. If you're not sure, you're like 25 x2. You have an x2 button here. Square it, and then you get 625, right? So don't sweat it. You always have that available. So this is 20 centimeters squared. And this is, you can put an x there for now. You just want a placeholder. So cross multiply. So that's 4x, right? Is equal to 625 times 20. I will divide both sides by 4. The 4's cancel out, so it's really 625 times 20 divided by 4, which is 3125 centimeters squared. This is the area of the actual, like the amount of fabric, right? Fabric is covering, so you're thinking area, I'm hoping. And B, cost. Since we need 325 centimeters squared, we just multiply it by the cost, which is 275, and I was nice enough to already make that in centimeters squared, so they just cancel out like that. So it's really just 3125 times 275. And I just made this up, so don't think that this is what the actual price is. Pretty expensive kite. There it is. It's supposed to be meters squared, but I haven't shown you how to do that yet. So We'll just leave it at that. Okay, hold on. Yep. Page 7, booklet, page 7. Just do 1 to 7 right now. 1 to 7, which is all page 7 basically. I will post the key later today.